Hello, everyone. Welcome to the Metaverse Hackathon workshop with OpenSea on programmatic collections with OpenSea's API. Today, we've got Adam Montgomery with us today. Adam, welcome to the Metaverse Hackathon workshop. I'm going to hand over to you for you to introduce yourself.
Awesome. Hey, hey, nice to meet everybody. Yep, my name is Adam Montgomery. I'm on the engineering team here at OpenSea. I've also got Earl with us today, who is on our developer community side. Yeah, helping, I'm sure if you guys are in Discord or communicate with us in any way that way, I'm sure you recognize his name probably more than mine. Yeah, I look forward to kind of showing everybody some new API endpoints that we have set up and how to be able to use them.
Awesome. Thank you so much, Adam, and welcome, Earl. Nice to see you and nice to meet you both. And welcome everyone else to the Metaverse Hackathon. For those of you who I haven't met yet, I'm Alex. I'm the program manager for this hackathon event. So if you need any help and support, please do feel free to reach out. I will be putting in the chat box the link to your hacker packs for this hackathon and all the challenges for the hackathon there. I am aware that OpenSea's API is one of the challenges, so definitely have a look at them and pay attention because it could help you win a prize at the end of the hackathon. Awesome. So Adam and Earl, I'm going to hand over to you.
Awesome. Maybe we'll start. Interested in sort of people's kind of experience so far. Maybe I'm not sure we can do like hand showing or something, but like just curious. So who has used OpenSea's API at all so far? All right, awesome. We got one. Perfect. Two. Ooh, excellent. All right. That's okay. This is where all the on-call instances are coming from. All right, perfect. Well, yeah. So kind of how about let's see who has purchased or like kind of dealt with NFTs or like kind of an NFT marketplace. Or all right. Okay. All right. We got a few. Perfect. Awesome. All right. We got the NFT fans. All right. Excellent. Well, yeah. So kind of what the idea of what I wanted to cover today was we have added some new some endpoints recently to make what's called, so like when you're, like OpenSea is a NFT marketplace. So people list NFTs for sale with us, and then also people can bid on NFTs. So before, until recently, our on-chain contract, which the previous one was called Wyvern, really only supported a making offers on specific NFTs in like a collection. So say you have like a Bored Ape Yacht Club, you can offer, be like, hey, I'll buy, token number 65 for like 10 ETH or whatever. So you can make these individual offers on like on different items in a collection, but you couldn't until recently do what we call like a collection offer, which is what you're saying is like, hey, I'm going to be willing to buy an NFT, any NFT in this collection for some given amount of ETH. So what we've added recently is the ability to make these collection offers, and we had them on our front end, so you could go through OpenSea and you can create them there. And we've recently added it now to our API as well. So we have like a certain set of people that like kind of make these offers and kind of interact with our marketplace programmatically through the API. So yeah, what I covered today is just how to do that, and kind of like starting from first principles with creating a wallet. So I'm not a big fan of slides, so let's hop into some code and look at some interesting stuff here. All right. So here is the repo that I built here for this demo. I'll put in the chat here the a link to the GitHub, the repo for it. And kind of what I'll do here is sort of like step through sort of the initial process here of like everything that kind of goes into making an offer on OpenSea. So kind of the first thing we need is a wallet, so to be able to make these offers from. So what we do here is, I guess, and maybe this is an interesting one. So how many people know how to make an EVM wallet programmatically? Perfect. All right. Well, everyone's going to learn soon. Okay. So what we do is, first thing we start with is just a script here to create a new wallet from scratch. So what we're doing here is just this. This is kind of a common practice. In general, you don't want to be using like you have like a wallet that you use, for like activity, like, buying and selling things, and like have it hooked up in MetaMask. In general, if you're using the API, you should be operating with like a specific single purpose wallet for it. Keeps everything isolated, and there's always potential for like bugs in code. So you do want to sort of like put some barriers up there so you don't end up kind of accidentally spending a bunch of your ETH on something you didn't intend to. But yeah, so here is the code to create a new wallet. So what I'm using here is ethers. So this is all in TypeScript, and it is ethers is one of a couple libraries. The other main one is Web3. People have preferences on either, but all you really do is, like, behind the scenes, a crypto wallet is really just a set of like random bytes, and then you encode that in hex, and that becomes a private key. So this is what the script is doing, is just creating a private key for you, and outputting the wallet address for that. So I think if everyone, like, the easiest thing here is probably for people to to follow along. If you like have time to check out the repo, I kind of go through this part and explain. And there is a script here in the README to, once you've installed so I use NVM. You don't necessarily have to get a node version there, and install your dependencies. So that'll be the first thing you want to do, is to create a wallet. And then what I'll do is I'll put that wallet here in this .env file. So this is a single purpose one that I just created here. Obviously now the key is leaked, so it's everybody's wallet now. So yeah, so that's what this first script does, is just to create. So I can probably just like run it while we do it here. That's something like that. All right, let me share the rest of my screen here. Okay, well, I'll talk through this. So this creates a wallet. You add this now to your .env file. So the next piece that we want to do is, there's, I guess, a few pieces here now that come into making an offer on OpenSea. So right now I have a wallet. First thing I need to do now is to get some ETH in it. So for this demo, I'll just do everything in test nets. So you can see, let's pull up the Gurley faucet here. Perfect. So for Gurley is our test net on for Ethereum. So in general, every chain that we support will also have a testnet version. So OpenSea maintains two versions of our website. There's OpenSea.io, which is like our main website. And then there's testnets.opensea.io as well, which now operates on just those testnets. So this is not real money that's being used here. And you can do like all of your development and testing on here. We also do not require API keys for testnets. So you can hit our testnet, you hit our testnets APIs and not have to worry about having a key. So let's see, let me just create this up in here. So there's also, to follow along with all of our documentation, we have, so docs.opensea.io is where all of our endpoints are documented. You can request an API key here. There's probably some way, if you can, like, there's a bit of a backlog with API keys, but if you figure out how to ping me or drop something in the chat here, I'll see what I can do to help. So all of these new endpoints that we have created are under the 2.0 namespace. So we have version 1 and version 2. Version 2 is got most of the things that we'll be interested in today. And yeah, you can see here under the API reference, these new collection endpoints that we've labeled with beta. So just kind of cover them quickly here. We basically have, like, so the types of offer I was talking about earlier. To make a collection offer, what we do is we support retrieving those collection offers. So you can see the offers that other people have made, and we support creating them. So this is what we'll be using today. So this allows us to post a collection offer. So that can be used on OpenSea. And you can see what this is the payload that you have to send, which I'll explain, because it looks like there's a lot to it, because kind of there is, but it's not super complicated how we build this. And then I'll get into the reasons for why we have this endpoint here in a second, but we also have an endpoint that helps you build a collection offer. So that helps, yeah, I'll explain that in a second here. But yeah, so I guess so far, yeah, how are we following along? How's everybody feeling about it? Any questions or anything so far? Let me check and see if there's anything in the chat. Let's see, Richard. Yeah, okay, yep. Larry's the person to ping on the API keys. He's our keeper of the keys. Any other questions before we keep going here? Nope. All right, sounds good.
Sorry, quick question. Does OpenSea like pro to people essentially building like market making tools?
Oh yeah, definitely. Like this is yeah, that's what the idea behind these endpoints are, to be able to programmatically add orders. And yeah, we do have people that that use them for buying and selling and in automated ways like that.
Cool. And then the second thing really quickly is for trait offers, I know that you have both like normal traits and then you have like stats as well. Like there's a slight difference between the two. I guess, does the trait offers also apply to like stats, or is it purely on the attribute traits?
Yeah, so traits are defined by creators of collections. So they're like, a trait is defined on an NFT. So say it's like, it has a hat, the hat is red. So that is, I mean, technically they can be mutable, like the contract can be mutable, but the stats are really just like our perception and like our counting of like how those.
Right. Oh, yeah.
So yeah, end up being.
Okay. Thanks.
All right, sounds good. So, okay, so we got the endpoints. All right, so first thing we've had is, so we've created a new wallet here with this create wallet. So let's see, we'll cover the next piece then. Let's see. So bidding bot actually defines how the full steps that we're taking to make this offer. So let's see. So I guess there's the first thing to cover is just like the collection. So all right, we have to figure out which collection we want to make this offer on. So what we can do is you can go over to testnets and see all the collections here, or at least some of the trending ones. I sort of picked one kind of at random. I'm not sure this is actually Bored Apes real collection or not. Kind of hard to tell on testnets, but oops, wrong one. But let's see, here's the collection that we're going to make these collection offers on. So you can see now they've got a set of NFTs in the collection already, and you can actually see here that it's possible for us to just make a collection offer directly on the UI here. So usually what I do as a first step, so whenever you create a new wallet, there's some steps you have to go through in order to have that wallet be able to interact with OpenSea. So the first one is, well, to be able to place offers, really. The first one is that you just need to have, it needs to have some amount of ETH in it. So the girly faucet's the best place to get girly there. Usually what I do is you can these other steps you can do programmatically if you want, but I find it's just sort of easier for this purpose to just kind of do it with manually through MetaMask. So what I'll do is after I finish creating this new wallet here, I'll import this private key into MetaMask, and then you can just go to OpenSea directly here. And this is actually probably the easiest place to first, we have to basically what's called wrapping our tokens. And then the second thing we need to do is we have to approve that wrap token. So, so wrapping is the process of converting ETH, which is what is sort of natively like the native token for Ethereum, into what's called WETH, which is basically just a smart contract that you send your ETH to, and it's held basically in escrow for you, subject to some rules that you can basically say like, hey, certain people are allowed to access that. Like you can share control of your ETH. And when ETH is just in a wallet by itself, can only be controlled by the private key that owns that wallet. When it's been put into this contract called WETH, what we can do is we can tell WETH, hey, I'm going to go use that ETH now to place offers on collections. And you tell the WETH contract, hey, allow OpenSea's marketplace contract, if it has the signed order, to take some of that ETH out to fulfill these offers that I'm making. So that's why we can't just like, when we place offers, we always place offers with the wrapped form of the currency, not the native form of the currency. And the easiest place to do that is on, and honestly, probably, yeah, well, the easiest place to do that is the sidebar here for at OpenSea. So you can see here that I've already wrapped some ETH. There's a little button on the side here. All you do is you click on it, and then you just hit wrap. And then this will provide you like an interface to just say like, hey, here's how much ETH I have, and I want to wrap like 0.001. And then it will use, it ticks off a transaction. So what I'm doing here is I'm sending ETH from my wallet to the contract, and the contract knows it's coming from me, and it stores it in basically my bank account on the contract. So we can kick that off here. So this is on-chain transaction, cost gas on ETH. It'll cost like real money to pay the gas. So the wrap happens. And then the second part now, so now my ETH is now in the ETH contract. I need to now authorize OpenSea's marketplace contract to access that ETH. So what we do is we present you, when you go to make an offer on OpenSea, the first thing we do to check here is, and I've already done it for this wallet, but if you go to do it with one that you've created fresh, you'll get a first screen ahead of this. That'll basically say, hey, you need to authorize Seaport, our contract, to access your ETH. And then what'll happen is if your offers are accepted, Seaport will go in, reach in, take the amount of ETH out that you authorized for the offer, and use that to like basically give that to the seller in exchange for the NFT and send the NFT to you. So I've already done that for this one. I can just show you what it looks like to just create a collection offer here through the UI, which is pretty simple. We have just basically, you create a signature request here that is actually signing the actual order for it. So we'll see here, there's a lot of fields in here, but MetaMask still has this bug. You have to click on this button to go to the bottom. But yeah, this is basically the same thing that we're going to be building right here. But instead of having MetaMask give you this sign button, we're going to be doing it all programmatically. So that is the flow for creating collection offers. Just want to stop again. I know there's a kind of a lot of info that kind of goes into making these. So is there any kind of questions so far? Anything that anyone's not understanding?
Hey, Adam, a user asked, can people accept orders on flagged NFTs?
So that part's kind of kind of complicated answer, but can they accept offers on NFTs? So what we do is we prevent that from happening through our UI. There are certain situations where flagged items can potentially be used, but basically what we do is we do our best to prevent that from happening. So I guess the short answer would be it's difficult but not impossible. And as fast as we try to make our systems to detect these things and block them, that there's still always that little at least a little bit of gap there before we detect things.
And once it's detected on your side, is it possible still, I guess, like after that gap has elapsed, is it still possible, just difficult, or is it actually not possible anymore?
I'll explain part of how the order comes together, because it's very difficult but not impossible is what I would say. There's certain situations where it is possible. There's only so much we can do to prevent things that are happening on chain, but we do a decent amount to be able to prevent that. So it's not impossible, but it is very difficult. So yeah, maybe I'll cover that, because that's sort of I think the next big piece that I kind of have to cover is to sort of explain how what the actual order is and everything that we're signing. So I'll explain now why, like what makes that difficult actually. So here first I'll start with kind of like a little trick that I use when I'm like dealing with stuff on OpenSea, especially like kind of building things against it. So kind of what you can do is sort of the network tab here is a pretty good friend for figuring out like a lot of like if you're seeing signature requests and things that we're doing to try to figure out like what some of the reasoning is behind some of these requests. So I'll start with just like, okay, we're making a collection offer here and say that I'm gonna put it for like this much ETH and make offer. And now you see I'm coming back. I have a signature request. So it's like, okay, well, what happened there? So what we can do is we can go and I will be able to recognize hopefully what it is. Collection offer. Create collection offer. Here we go. All right, so here you can see how us creating this collection offer actions. So this is us sending to the front end the order that we want you to sign. So you can see that what we have sent up there is we're telling it basically, hey, for this is the amount that we are, the amount that we're willing to pay for it. And then it's showing you like what the price is and then what the contract that we're making the offer against. And then you can see kind of coming back in this message, what the message it is that we need to sign and how we need to sign it. So you can see that we're sending back this client message and then we're signing it with typed data. So let's actually just take a look here and see like what the actual payload is there. So so you see like there's a few fields that are being sent back here. There's this types, there's a types, a domain, and a message. So the message here in this case is the actual order that we are looking to sign. So whenever you're buying and selling NFTs on OpenSea, you're using our marketplace contract called Seaport. And what you're doing is you're submitting what's called an order, and it's basically explaining, hey, here's who I am, here's what I'm offering, and here's what I want to be paid for it. So it's pretty simple like construct that can apply in both situations to either I'm placing a listing or I'm placing an offer. So if I'm placing a listing, what you're saying is, hey, I'm offering you an NFT, and in consideration, and so in payment for that, I want a certain number, I want certain things. And those things are going to be, I want to be paid for the NFT, I want the creator royalty to be paid, and then I want OpenSea's platform fee to be paid. So in those cases, so I'll have for a listing, it'll be off, the offer here is the NFT and the consideration is the payment. For an offer, which what we're creating here is you're saying I'm offering money, basically. So some amount of WETH. So this is how much WETH in Way I'm offering for this NFT. And in consideration for that, I want a few things. I want an NFT, I want the creator royalty to be paid, and I want OpenSea's royalty to be paid. So that's what these three consideration items are. So we have offerer, which is me. We have what I'm offering, which is money, and what I'm looking for in exchange for it, which is this one is the NFT. This one I'll explain what exactly is in here in a second, but like this is the platform fee, and then this is the creator royalty to be paid. And I'm saying some other things about it too. I'm saying, hey, I want this order is starting at this time. This is just an epoch timestamp, so we can show you how to generate that. I want it to expire at this time, so if it's not filled by then, it just expires and it's just not fillable anymore. Defining what type of order I'm making, and then this zone and zone hash are these are components of how Seaport works that we won't cover today. Salt is just a random number, which we'll kind of cover the reasons for that maybe later. Conduit key, similar. And then total consideration items is just listing out the number of consideration items there. We won't cover the reason for that today. And then counter is just a way to allow you to easily cancel orders, which also we probably won't get too into. Yeah, so this is basically, this message is what we need to build in order for us to sign it. So like when the front end is, you type everything in, we send it to you all pre-built for it. And instead now what we're going to do is we're going to figure out how to do it, how to build this ourselves. So let's dig in just a little bit more into these offer and consideration items. I'm just gonna pause again briefly. Any kind of questions here we have so far?
I put 2 questions in the chat. Can you specify like an offer with metadata? Like, you know, I want any NFT, but it has to have like a red hat or an eye patch.
Yep, exactly. So this is like collection offers here are like part of a broader category of what we call criteria offers. So yeah, you can specify in certain cases certain types of criteria. And yeah, I'll show you when we go into the identifier how you specify it. But yeah, it is possible, and we do accept trade offers as well for certain collections. The creators have to opt into them because of how the traits work. We have to make sure that the traits are stable. Otherwise, if things are moving around, it's hard to encode that information.
And I just had one more. Is there a way can you auto cancel orders in case the floor price drops like below your offer?
Yeah.
Price?
Yeah, there's a bulk cancel capability in Seaport, and basically all it does is it's very simple. It's like this counter at the bottom. What that does is like you'll place a whole bunch of offers and just leave counter at 0, and then all you do is you call the contract and you say increment my counter, and then every offer that has a counter lower than the new number. So if it's 0, you increment it to 1. All the offers that had 0 immediately become unfillable. So you can bulk cancel basically every order that you've made so far. But there's one kind of critical part to understand about that is that like once you make an offer on OpenSea, and once we have it, we send it out via our API so that other people can consume them. Once that offer is signed, it's not us that controls it. It's the marketplace contract. So for you to cancel that order once it's been placed and sent out, you do need to cancel it on chain with that. There's no way that we can cancel it for you. All right, so let's cover then. So a little bit more of like the struct, the info that's actually in this message that we're building. So the best place to get like the raw reference data for this is the OpenSea Seaport repo. So we have like for probably like the Seaport's got probably some of the best docs I've seen on a project. Not to toot our own horn here too much, but like it's really well done. I would suggest reading, like, it's just honestly it's a really very elegant system. And this has mainly been built by someone on our team named Zero Age, who's like just a wizard with EVM. So if you want some inspiration on like some cool stuff you can do with EVM, I suggest like digging through this repo. You can look at the reference implementation too. The actual implementation has a bunch of assembly written in it to optimize for gas. And it's a little hard to follow, but the reference implementation here is under reference is like kind of an easy Solidity way to kind of follow along with what's happening. But yeah, all the data, all the structs, everything is being defined in this repo. So if you want to like figure out exactly what each of these things are, this is the place to do it. So let's see. So yeah, let's dig a little bit more into our offer. So in the offer, like I mentioned, we're making an offer, we're offering money. So what that is, so the first thing is that this struct defines the type of item here. I wonder, does item type actually get defined in here too? No, unfortunately. But yeah, so item types in here are basically an enum that let's see, actually defined. Where it's defined here, we can see, we can see with the numbers. Let's see, should be maybe struct enum type. Or no, never mind, it's an enum. Enum item type. Oh, there we go. All right, so so we can see here what these numbers map to. So here we have item type of 1, which corresponds to a ERC20. So that makes sense. So WETH is an ERC20 token. So that's what it's defining what the type of this this first item is. So okay, we have an ERC20, and then token points at the contract address. So on the WETH contract address on Gurley is this string here. So if we go to, Gurley Etherscan, Here we go. So here is the ETH contract. So yeah, so you can just see like this is the contract that we're working with, and kind of when I explained earlier, like this is just basically holding these funds effectively like kind of an escrow for us. Identifier criteria here is used in the other for the other item types, but in this case, when it's an ERC20, it's basically just unused because there's not like. For an ERC 721, you would have a token ID, but within 20, there's no token ID, so it's just 0. And then start amount and end amount in this case is specified in way. So yeah, that's basically what's a 10 to the 18th part of ETH. So and in this case, we're not doing anything. There's no movement between the numbers. So start amount and end amount is the same for certain types of auctions. Like you can have like a Dutch auction that decreases over time, but for us, we're just specifying one number. So this is just the amount of way that we're offering. So that's the offer. And then now we're moving to the consideration. So the first one, so we have item type of 4 here. So that corresponds to, where did it go? Consideration item. So 0, 1, 2, 3, 4, ERC 721 with criteria. So like I mentioned before, we're making criteria offers. So what this is saying is like, hey, what I'm asking for is an ERC 721 criteria or ERC 721 token, and I'm specifying criteria on it. So it defines what the rest of the fields mean. So, all right, that makes sense. And then token. So we're looking for this here is the contract address for we're making the collection offer against. So in this case, it's this this kind of Bored Apes one that we were looking at earlier. So what we've done is we've looked up and figured out, okay, here's what the token address is for it. I'll skip over the next one. So start amount and end amount are the same. We just want one of them. That's all we're asking for. If we're making an offer and trying to get like 3 or 4 of them, then this could be number 3. And then recipient is defining like, I want this in like, so you're saying I'm offering something, I want something in return, and that in return that needs to be sent to a certain address. So what this enables us to do in this case, recipient is this 07FC, which is the same as the offer. So what I'm saying is in exchange, I want this NFT sent back to me. It's implied on the offer that when you're offering something, it's going to the buyer. So, or it was going to whoever's accepting the offer. So in this case, this recipient is me. I'll cover this identifier criteria last year because this one's kind of interesting. But I'll just to cover the other ones are pretty simple for the platform fee. And I just know this one's the platform fee because this recipient address is OpenSea's platform fee wallet. So that's what's being sent there. And this maps to 2.5% of the purchase price, which is what the platform fee is. Item type of 1 is that ERC20. So basically, and then this is the WETH address here that we saw above. So basically, it's just saying, hey, send me 2.5% of the purchase price to OpenSea. It's the platform fee. And then this one is the creator royalty. And similarly, you can look and see that this is going to be roughly, I think this is either 10% or 1% of the total fee as well, being sent to this the creator's wallet. Same idea, it's sending the WETH. So with the exception of this long identifier criteria, is everyone following along with how to look at what these different items are in the offer and consideration?
Quick question, is the start amount and end amount for the OpenSea fee and the creator royalties, is that an absolute value or relative? Just because it's 2.5, it's 25 and 10.
Yeah, it's calculated relative to the purchase price, but everything is like basically set and hard coded in the order. But yeah, it is calculated at 2.5% of this number, and then royalties or the creator fees are calculated based on creator fee percentage times the price.
Right, and so the number that we input though is that so the start amount itself, is that meant to represent 2.5%? As in, so for example, if the start amount for the bid was, or for the offer was, I don't know, double that, would the number for the OpenSea number still be 25 million or whatever it is, or would it be 5? Would it be 5,0,0,0,0 to the 8 to the? Do you get what I mean?
5. Yeah,
Okay,
you're right.
cool.
Yeah, just
Absolute.
yeah. If this was 5, you multiply this by 5 as well.
Okay, cool. That's fine. Got you.
And the start amount and amount we'll get. Yeah, you said these they all have to be there, but yeah, you're right. No, these are absolute values.
And so, if the royalties is incorrect, would the order fail? Would the collection offer fail, for example?
It will, so it's still a valid order, but when you try to send it to OpenSea, we'll look at it and then we run validation on it and we say like, oh, hey, the creator fee on this is incorrect. So we just won't, we won't accept it to our platform, but it's still a live order. You could go send it to somebody else and like, like Seaport operates completely independently of us. Seaport will accept the order and like, it's still valid, but OpenSea as a platform, like an off-chain platform, will not accept it.
Okay, and final question, and I think you've just answered it to some extent, but for the initial offer, you could technically have put in ERC 721 token, and you could have said for the consideration you want an ERC 721 token in exchange, right? So you could have essentially put like a swap for 2 NFTs, like an Azuki for a doodle or something like that, right? But OpenSea's API would reject that, but Seaport independently, you can use that to essentially create some sort of token swap platform, right?
Yeah, exactly. Yeah,
Got you.
There's a lot of like Seaport functionality there, and like these that's why this consideration, this offer is really powerful. There's a lot more like that the contract is capable of. Like you could swap an Azuki for 2 Bored Apes and like 1 WETH or something like that. You can make some pretty crazy kind of trades for it. It's pretty
right. No, that's super helpful. Thanks.
Definitely. All right, so yeah, we covered these ones. I think so. Start time and end time, and just epochs timestamps. Order type is ETH to ERC 721, which is interesting. That doesn't look like it was. Oh, wait, basic order type route. Order type full open. Sorry. So yeah, well, this explains it right here. No partial fills anyone can execute. So straightforward enough. That there's certain other aspects of Seaport too that we don't have to like super dig into today, but like there's other types of you can like put certain types of restrictions and have certain zones. So definitely encourage you to look through the repo if you find that interesting. But for us, this is just like a standard full open order. Okay, good. We covered those ones. So last part here to dig into is this identifier or criteria. So what this does is, in a normal, if you're normally just making an offer here, if this item type was say just ERC 721. So if I made this, if this was 2, this identifier criteria would just be the token ID. So it'd just be like 1, 2, 3. And then this is me making a offer here specifically just for one specific token. But what we're doing now is we're doing this special type of item that is applies to a large collection of potential tokens. So what we do here is, what this is a Merkle tree root. So maybe that's a good one. How many people are familiar with how Merkle trees work? All right, okay, good. So this one's where it gets like super interesting. So what a Merkle tree is it's basically just it's a way of encoding multiple token IDs into one set of data, so that we can define basically a list in like a way that's very interesting and has some cool properties. So let's just say that we want to make there's 4 tokens that we want. So let's see, I'll make this one 1, 2, 3, and 4. And what a Merkle tree does is it allows us to encode these into a tree. And then what the tree does is it takes these tokens in order and builds them into like a little tree. Let's see how my art works here, and then I'll explain how they all come together. The tree, and then the tree works like this. There we go. So all of these token IDs here, what we do is we take them and we hash basically 1 and 2. So imagine taking a hash of 1 and 2 together. That is what this node represents. And then this one is similarly the hash of 3 and 4, which is these two hashed together. And then what this one is this one is the hash of basically the hash of 1 and 2 and the hash of 3 and 4. So what we're doing is we're basically building a tree here by just like progressively hashing these different nodes together. And then what this does then is this gives us one string at the end of the day. And in this case, it's this long blob here. But what that does is this allows us to say like, okay, I'm making a collection offer. What OpenSea is doing on the back end in these situations, especially for like on the front end, is that we are saying like, okay, hey, you want to make an offer that applies to this entire collection. There's say 10,000 NFTs in that collection. We build this Merkle tree in the background, and then send you basically the top node at the end and encode that in the offer. And then, so what's happening then is that this allows us to specify just a certain list of tokens, and no matter how many tokens are in this list, the size of this blob is the same. So that's the cool thing, is that like I can make it this for like, you know, you can put 100 million items in this size of a tree. It's still at the end of the day just one big hash at the end. And then what you want to do is, in order to fulfill that offer, what you need to do is you need to bring to the contract both this hash at the top, and you also have to bring what's called a proof, which is basically say, if I'm fulfilling this for item 3, you have to tell me, how do I get from 3 to the top? So I have to bring, oh, hey, I can make curvy arrows. So I have to bring basically this, well, never mind. All right. There we go. So you have to bring a proof which defines the pathway from how I get from the node that you're looking to fulfill the offer with to the top. And then this is a cryptographically secure way to encode in a fixed amount of data, an arbitrarily large tree, and combine it with some off-chain process to define like, okay, hey, this is a proof that I made this tree. This is what the tree looks like. And here's how you can prove that this node is in that tree without having to, without having to like provide that information or store that information on chain, which would be extremely expensive, especially for such a large tree as this. So that's why Merkle trees, you'll see, are like a very common concept used just in crypto in general, because it has those very nice properties. So a question came up earlier is like, well, how do I, if an item is flagged, how can I get somebody to not be able to accept that offer anymore? What'll happen is OpenSea will stop saying like, hey, if 3 is no longer a token that we allow on the platform for whatever reason, what we'll do is when you come to ask us, how do I get from 3 to the top, we won't vend that information anymore. So this tree, once the tree is created, the tree is always going to be the tree. It's like a immutable data structure. This collection of hashes at the top is always going to be what it is. But what we'll do is we stop sending the proof for this. So that's basically why it's not impossible, but it is just very difficult for if an item has been flagged by us to fulfill these offers. So that's how the piece of this Merkle tree. And I know this one's sort of like a little bit of an interesting kind of computer science type exploration. Are there questions on how these Merkle trees work, or what this identifier criteria is?
Can I speak here?
Yep.
Hi, Adam. Yes. So this is really an awesome concept. I wasn't aware of Merkle trees yet. So next question is, can we build those Merkle trees on our own? So if we want to combine certain traits or maybe other market parameters, like if an item is listed, and then build a Merkle tree on the base of all the token IDs and use it with your API?
So no, we do not. We don't support arbitrary Merkle trees being generated for these. What we do is, and then this is the reason that the build endpoint exists, is that what you can do is you can ask us, you can place collections with either a collection, like place offers with either a collection offer or a trade offer, and we'll build the trees for you. But yeah, we don't support currently making an offer that applies to a custom subset of tokens, which is what would be happening in that case. So we'll just say, hey, this is the one tree, like you say, like, hey, these are the types of offers, and then we'll tell you what the tree is, but we don't support it the other way around where you like kind of bring your own tree.
And is this a cryptographic limitation? So do you need to build a tree based on public and private keys, so only you can verify the structure? Or is it just a limitation of the API and implementation right now?
Just a limitation of the API. Yeah, there's no non-public information in the trees. The structure of the trees can be like, if we generate the tree, it's not necessarily that we generate the tree in 1, 2, 3, 4 like this. You can generate them in different shapes.
Okay.
There's nothing, no proprietary or non-public data goes into the tree generation.
Awesome. Thank you so much.
Yeah, definitely. Alrighty. So yeah, so this is how the tree. So now we've covered basically this is the entire order that we're building. So now let's take a look at like the code for how we build it, which is actually pretty straightforward once you have that. So let's just do the bidding bot. So let's see. So what we covered. Yeah. So we have the collection slug that we're making. We're looking for an offer to build an offer just with a quantity of 1. We're paying this much in way. It's just, it's 10 to the 18. Just be careful. Like, you generally want to use like big integers here. JavaScript doesn't handle very large integers, so we encode a lot of them as strings, even though they're actually integer values. So yeah, so then we have to figure out what the creator fee and the creator fee recipient is. And I'll be honest, like, this is not like the right now, the best way to do this is either you can pull from the API and look for creator fee percentages, or you can do what I did just now, which was you basically pull like an sample order from a collection, and based on this number. So the platform fee is always 2.5%. The creator fee and the creator fee recipient I can get from here by basically looking at what the amount is relative to this, relative to the offer amount, and then this is the recipient. We do also have that through the API through a different endpoint. So you can call a, let's see, I believe it's under V1, retrieve collections, and it's retrieve a collection. So Doodle's official. Let's see here, try it. So it will be available here under dev. Where'd it go? Dev seller fee basis points. So basis point is 1/100th of a percent. So this is a 5% fee. And then the payout address is the other one. Let me just double check, make sure that is the correct one. Payout address. Sorry, we should put some more documentation on this. But yeah, payout address for the royalty seller fees. Wait, do one. Yeah, here it is. Okay, it's also under C. So yeah, this would be a better place to get it. So fees, seller fees, 500 basis points to this payout address. So that's how you define. So you can pull this from the API as well for a given collection. And then we're encoding that here into this build offer. So basically, to cover the high level of what this flow does, we're going to build an offer. We're going to then sign the offer, and then we're going to send the offer to OpenSea. So let's see. So for the building the offer, we're basically going to take all those pieces that I covered before, and this is all in the repo, so we can kind of read this in like slower later. But yeah, the idea is like, okay, I'm starting it like expiration. So the order starts now and ends in whatever expiration seconds that I want to give it. We can get what the consideration item is. So getting consideration fills that the consideration, the 3 items in that array that we covered. The only kind of more complicated one is the get token consideration. So what this is doing is, in order for us to get the Merkle tree, this V2 offers build endpoint, when called with who the offer is, the quantity, and the criteria, will send back what the Merkle tree is really the interesting piece that we want to get back from there. So go to V2, build a collection offer. this is what you get back. And then really what we're after is this piece here. So recipient is just going to be you, start and end amount is 1. I guess you also need the token address as well. So this is the contract address for the collection. So this is the collection, and then this is the Merkle tree with the list of identifiers in it that you want to use. So we're going to be expanding this payload later. So instead of what we're doing right now, which you'll see the rest of the repo covers like how to build the entire offer. This is sort of the one tricky part, and you definitely need to get this from us because we're the ones building the Merkle tree. And then similarly, you can see if you make a trade offer, it builds you just a different Merkle tree on the same contract address. Let's see. So get token consideration. We kind of go back. So token consideration, we get the platform fee, which is basically just fee basis points times the price, and set to the open fee recipient, also paid in ETH, item type of 1, CRC20. We get the creator fee, basically same idea, basis points times the fee, sent to, in this case, the recipient being the creator royalty address. I mentioned the salt's just a random number, throw anything in there, it's fine. These are used to deduplicate between multiple orders. So if you make the same offer twice, you have to make the salt different for them, but you could actually just use the same salt a bunch of times. It doesn't really actually make much difference. And then, yeah, build offer itself gets those considerations. It gets the, builds the offer. We're making a ERC 721 criteria order for it. And yeah, I think this is, the zone and zone hash are just, these are just hard coded at the top. So fee recipient doesn't change, zone and zone hash don't change currently, conduit key doesn't change either. These are just like hard coded. Yep, so that's how we actually build the offer. And then let's see. The signing the offer is also pretty straightforward. You just get the wallet based on the private key and sign it. With the type data, signing type data is just it's a good security mechanism to make it a little bit more clear to users what they're signing. And the only added thing that you have to do here is you basically have to bring with you a definition for the domain, which is just hard coded here. You can just use this directly. This will be different for this chain ID. Yeah, domain will be different for if you make non-testnet offers. So this chain ID changes to 1 if you're on mainnet. These parts won't change. This is just basically, these are just schemas so that the model can understand, so the wallet can understand what it's signing and how to encode it. Similarly, so we send back a slightly different payload for signing with Web3. But yeah, you can just take this directly from the repo and this will work. And then so that's signing, and then posting the offer is also just pretty straightforward. You have to build this like criteria object to tell us like, hey, I'm trying to make this a collection offer on this collection. We need that information as well because it's not always clear to us based on the rest of the payload what you're trying to do. So this basically makes it explicit so that we can verify and validate the offer was built correctly. And yeah, you just post it to the endpoint, and let's see. And yeah, then you get a offer posted. Let me just so actually I'll just go run it in the all right, maybe I can just run it here directly. Gonna complain about the node version. And promising. Posted. So you can actually go now see the see the order here. Let's see, we do best offer, collection offers. Let's see one here. Hey, submitted by me 15 seconds ago. So ta-da, we were making offers. So yeah, that's the yes, that's the flow. The only other thing that's a little bit janky that I honestly didn't realize until I built this is that you we have a rate limit, so you can't make a request to the first endpoint and then the second one. So I put a little delay, 2000. Hope this will go away soon. I realized that we're being a little aggressive with the rate limits there. But yeah, the as far as how to fill these pieces in the creator fee recipient, I showed how to get that from the API. And then yeah, just make sure you're putting this price is in way. Just be careful with that. And yeah, and then yeah, this should be runnable. And you can use something you can use to make collection offers directly against OpenSea. So I think I got a few minutes left. Are there any questions I can answer about this?
Yeah, quick one. Sorry, I've asked you a lot of questions. Yeah, very, very quick one. Is everything available via like REST APIs as well, or is it purely through the SDK?
So this actually doesn't. This uses the API directly. So the SDK we don't have support for it yet. API client though is just an Axios client, just calling against that base jar.
Cool. That's fine.
So we can still use our OpenSea API key. We need to generate a new one. How does that work?
To generate what? Sorry.
The key, the API key.
Yeah. So
is there a new key, or we can use the existing one we have? Like I have a partner one.
Oh, existing keys will work. They're not necessary for testnets, but on mainnet, you just add headers here. There we go with that. Copilot, man, that's crazy stuff. So yeah, this is how you do.
So it remains the same API. It's just the new feature set that it's been added then.
Yeah, we just added it under the V2 namespace. Uses the existing API keys, and these are just new endpoints under V2.
The smart contract we're signing and interacting with, it's a new smart contract, or it remains under the umbrella of the OpenSea smart contracts?
Yeah, it's a smart contract we migrated to a few months ago, but it's like our main OpenSea smart contract. It's not like it's a smart contract and it's deployed on chain. It's not like controlled by us. But yeah, we did build it. And so yeah, it's Seaport. It's our main marketplace.
And in the last minute, is there any interesting products that OpenSea is keen to see built on top of that API at the moment?
Yeah, we're like this is a new one of like all being able to make collection offers. So that's the one thing, like a lot of people will take our orders and use them to like fulfill and display other things. Haven't seen a lot of interesting ways for people to submit new offers and new listings to OpenSea. So I think that would be, that'd be the thing that we're most interested to see.
Cool.
So excellent. Yeah, so let's see. So there is, I'm sure, Alex, I'm going to share like my email address with the group here. If there's anything that you guys run into like building the stuff, happy to help. And yeah, it was kind of fun going through that. I enjoy talking about our APIs and all the cool stuff you can build with it.
It was awesome. Thank you so much, Adam. And thank you so much for being here today and answering everybody's questions. Really loved your energy. I can just feel like your excitement about it. And it's so awesome. Do you mind if we quickly take a screenshot? Like everyone just put their cameras on so I can take a quick photo. I'd absolutely love to do that. And then I'll let you go, Adam. Thank you so much for being here.
My pleasure.
Awesome. Everyone, put your cameras on and just put your favorite emoji like I've just done, and I'll take a quick screenshot. And yeah, 3, 2, 1, smile. Awesome. Thank you. Thank you for being here. Adam, again, thank you so much for taking the time to speak to us today. If any of you do have questions, Adam, is your email the best place for them to reach out?
Yep, that'd be the easiest. It's just basically my name at OpenSea.io.
Perfect. Contact Adam at OpenSea.io, and yeah, feel free to reach out. Thank you, everyone. Thank you so much, Earl. Thanks for being here. Have a lovely evening.